Vectors. Vectors are like a ray and a segment. Vectors are really the, if you think of how important segments and lines and planes and circles and squares and things like that are to mathematics, vectors are that important to physics. If you want to, physics and science really models everything that happens in the real world through mathematics. So we'll give an example here. If I apply, say, 1 pound of force, don't move. I apply 1 pound of force to Quinn's arm. Am I going to break that arm? No. That wasn't very nice. If I apply 200 pounds of force to her, might I break that arm? Now, here's the deal. Look at it, okay? In both situations, okay, you are applying force in the same direction. And vectors model the direction of that force. But they also model the amount of force, okay? So, vectors have this beginning point. It's called an initial point. As a terminal point. And then I talked about that force, okay? 1 pound versus 200 pounds. The length of this vector could really also be stated to be the magnitude or the force. Last thing I'll say is vectors have direction. Super important. So last hour wanted me to play the video from Despicable Me, where the vector dude starts going off about vectors. So I'll try to do that tomorrow. So I love that movie. I think it's so cute. All right. So given the following vector, draw examples of the other ones. So if that's vector v, what do you think negative v looks like? Opposite direction. So we could say start right there, and then we would go same length, but in the opposite direction. Do that to the best of my ability. We can. You could start it down further if you want to. That would be fine. What would 2v look like? Double the length. What would 1/2 v look like? What would negative 4v look like? Yeah. Something like that. So now what we want to do is we want to sketch examples of the vectors, and we're going to learn how to do vector addition and subtraction. If this is vector A, how would I draw negative A? And if this is B, that would be negative B. That's vector B. I'm going to use that in a second here. Right now I want to show A plus B. And here's how you draw that. You start with vector A, okay, which is right here. And when you get to the end of A, you then draw vector B. It goes in the same direction as B would go. Okay, so you just place it right there, And this becomes a drawing of A plus B. And so that vector actually ends up, so your book will show it like this. It will actually connect the two together. You know, this vector right here represents, represents A plus B. Okay, so that's where you end up. You can draw the top part where you draw the two vectors. That's what I like you to do. I know that you can connect the beginning to the end. It's not always drawn in there. It depends on what your purpose is, you know, what type of word problems we're constructing. But I think you can all see where we came up with that final one. What if I want to do A minus B? You would start with A and then you would draw negative B. So you would take this negative B and you would draw it to there. So A, negative B, that's where you would end up. What if I wanted to do B negative A? I would start with A, then at the end of, I'm sorry, B minus A. If I want to do B minus A, I would start with B, and at the end of B I would draw negative A. And you can see, again, you can draw from the beginning to the end to show exactly what's happening. We would do that if we were to, if we were going to do word problems, we draw stuff like that a lot more, but we're taking the word problems off the test just because we don't have time. Question? Just looking really for the end result. Okay. This is a component form of a vector. Instead of using parentheses, we use these kind of arrow-shaped parentheses. I suppose you could think that that connects with vectors because vectors have direction, so they kind of point. And what we do is we just subtract the x values, we subtract the y values of the points that the vector is formed by. And what this does is it moves the initial point to 0, 0. So, for example, find the component form of the following vectors given P is the initial point and Q is the terminal point. P is the initial point, 3, 4, Q is 7, 5. You don't have to draw a graph every time you do this. I just want to show you what's happening so you understand why we're doing what we're doing. If I go over 1, 2, 3, 4, 5, 6, 7, and up, say 1, 2, 3, 4, 5, P is over 3 and up 4, and Q is over 7 and up 5. That's my vector. Component form does this. Subtract the x values. What is x2 minus x1? 4. What is y2 minus y1? So look at, if we draw the vector 4, 1, see how those two vectors are the same? Just the starting points are different. And so anytime you put something in component vector form, you're translating it so that its beginning is at 0, 0. It's nice to begin at 0, 0. It makes problems better, easier to work with. Why don't you try P on your own? Okay, put it, you don't have to draw the picture, just subtract the values, put it in component form. It's 7, negative 3. That's the component form of that vector. Any questions how to do that? We want to find the magnitude of the vector, that's its length. And if we start at the origin, you know it's starting at 0, 0. Very similar to back when we were finding r, or we were finding the absolute value of z. Absolute value of z, we said, was the distance from the origin. In the same way, if you want to find the magnitude of the vector, that's the distance of the vector from the origin, which is simply equal to the square root of a squared plus b squared. Have you seen that before? So again, all we're learning is terminology right now. The magnitude of the vector is its length, which we calculate by using the Pythagorean theorem. Find the magnitude of each vector. What's 5 squared? Negative 2 squared? That's it. That's all you're being asked to do. That's it. So you know how to draw them. If it's the length, can it have negative value? Length always has positive value. So it's like this, because you asked a good question, okay? I can apply 50 pounds of force to this wall, right? I can also apply 50 pounds of force to Sini's desk. In both cases, the force is the same, is it not? The direction is different. Okay? Magnitude doesn't tell us direction, it only tells us how much force is applied. So we don't attach any numerical or positive or negative, really doesn't matter at this point. Okay? We just always write it positive. We looked at graphically how to add and subtract vectors. You saw how we did it by drawing. Now let's do it algebraically or numerically. All you need to do is combine horizontal and vertical components of the vector. So given A is the vector 1, 3 and B is the vector 2, negative 2, find the following. 3A would be A plus A plus A, which is 1, 3 plus 1, 3 plus 1, 3. Instead of writing it like that, what could I just do? Just, multiply the horizontal parts by 3, and multiply the vertical parts by 3. So this becomes 3, 9. Just add the horizontal parts together, add the vertical parts together. So what is 4b? 8, negative 8. A plus 2b. 1 plus 2 times 2 is 5. Very good. And 3 plus 2 times negative 2. Negative 1. 2a minus 5b. 2 minus 5 times 2. What's 2 minus 5 times 2? Negative 8. And then 2 times 3 minus 5 times negative 2. 2 times 3 is 6, plus 10 is 16. Are there any questions about what we did? Yes. Oh, I'm very, very sorry. I used A and B here, then I used A and B here, didn't I? Okay. Oh, actually that's okay. Yeah. So 2 times A. So this is my you need to do X and Y separately. So this is the horizontal component. So we did 2 times 1 minus 5 times 2. That gives us the horizontal component. Somebody had a question this last year, and I'm trying to wrap my mind around exactly where you're at, because I had it last year, now I'm not seeing it. Okay. Yep, just do the x's first, and then just do the y's second. Yep, I did both x's, and I did both y's. Yes. Yep. Now I remember. Half the class saw that last year, half the class didn't. I need to rethink how I do that. So let me see. I'll come answer your question individually. I'll do it one more time, and you'll see the example. S for Sini. Q for Quinn. Vector S has coordinates 1, 2. Vector Q has coordinates 3, 8. And we want to do A plus, S plus 2Q. I take the horizontal part of S, which is 1, plus 2 times the horizontal part of Q. So 1 plus 2 times 3, 7. Then I move to the vertical part. S is 2 now. Q is 8. 2 plus 2 times 8. 8. Is that better? Okay. Very good. Your assignment today is to work just on that stuff. What? Yes. Yeah, they're right over here.